I'd like to talk a moment about one of the fundamental and essential things we do here at Oasis is changing metabolism, changing the underlying metabolism. Because we now know, it's pretty clear, there's enough research out there, and there's a wonderful book by Dr. Thomas Seyfried, that cancer is a metabolic disease. It's not a nuclear disease. That means cancer is not caused by a genetic defect, but rather all gene changes, either genes being turned on or off or being mutated, is a downstream consequence of metabolic changes. So basically, if you understand that, then you know that working at that level is not even an option if you want to be successful for long-term remission of cancer. So what we're talking about here by metabolism is that all of us run on a glucose metabolism. And if you were to look at our glucose in our blood, it's always, somewhere between, when you wake up in the morning, it might be 50 or 60 if you're lucky. Most people wake up at 70 or 80. Anyway, so it can go high, and the standard of what's normal has changed, just like sizes have changed. Is that we run on glucose. We're glucose metabolizers. Now, when we're being breastfed as infants, we are basically on ketones. There's more fat than sugar, and so we're basically it's basically what you would call a ketogenic diet, a diet that produces ketones. So energy can be derived from fat or glucose. We're basically on glucose metabolism. And it's when this glucose metabolism gets out of range, out of the normal healthy condition, is when we see conditions like diabetes and heart disease. It underlies basically everything. There's a syndrome that was coined a few years ago called Syndrome X, which involves diabetes and heart disease. And it's really, basically, it's all due to too much food, overeating, impaired glucose metabolism. Now, the body tries to defend itself because it'll be killed by glucose. Glucose is bad news. It's important, just like oxygen is very important. Oxygen, breathing it at 21% in the atmosphere is really good. You put a mask of oxygen on at 100% and you keep it there, within a month you'll have emphysema. So yeah, it's good, but not too much or not too little. So that's the way it works. It's the same with glucose. So our body, to defend itself, becomes what's called insulin resistant. It downregulates, doesn't make as many insulin receptors, so that we don't, and that's what diabetes is, right? So, but in any case, why do diabetics have a higher risk of cancer? Okay, because cancer, again, what's happening is that cancer switches its whole metabolic process in the way that follows. Inside cancer cells, inside all cells are little mitochondria, which are the very efficient energy factories. They take 6 molecules of oxygen, 1 molecule of glucose, and produce 36 to 38 ATPs. ATPs are the energy molecules. Very, very efficient. But what happens when enough of them, they're very vulnerable to getting broken down. So if they're continually being bombarded by mutagens, radiation, carcinogens, free radicals, etc., all the things in our environment, microwaves, you name it, they're continually bombarding or surrounding the cell. We're swimming in this sea of toxins, putting perfumes and stuff like that on, smoking, whatever it is we do. Those are the most vulnerable part of the inside of the cell. So when they get damaged and the cell can no longer use that, it goes into a default mode of energy production called glycolysis, where it just ferments the sugar because it can't use oxygen. That's inefficient. It only makes 2 energy molecules, 2 ATPs for every molecule of glucose. So it needs a lot more sugar. So it goes, this is the metabolic change. Cancer cells are ravenous glucose eaters. So they change they upgrade insulin receptors, they upgrade glucosidases, they do anything they can to get more sugar, and they eat it, and their whole metabolism changes. So those changes that occur in the cancer cell have given it an advantage, and that is they don't commit suicide so often like other cells. They don't have what's called apoptosis, programmed cellular death. So they don't die, which is not a good thing for us. But anyway, so that's one of its advantages, but it doesn't have certain enzymes, and it does. So metabolic therapies are therapies that challenge cancer cell based on our knowledge of its limitations. Okay, so that way we can present it with a metabolic challenge that is, to a healthy cell, is good, or zero effect, and to the cancer cell it's lethal. So that's a completely different view than poisoning it with a toxin like a chemotherapy or radiation, or trying to, because killing it is a whole different thing. This is making it die. It goes through a normal regulated death, apoptotic death, when you do this. These are metabolic therapies. But we do that even with food. We have to change our diet. If we don't change what we're eating, it's the same thing as not quitting smoking. I mean, if I had lung cancer and I'm smoking cigarettes and I tell the doc, I just can't quit. I feel good when I smoke cigarettes. Sorry. Well, it would almost be unethical for the doctor to treat me, because he would know that it's irrelevant. Or if I started 9 months later after I quit, I got rid of the cancer, I started smoking again, and I'd say, that doctor really wasn't very good. I was better for a while, but now I got it again. Oh. Anyway, we get it when it comes to smoking, but we don't seem to get it when it comes to lifestyle. Going to bed early, essential. This is part of metabolic therapies. I won't go into it now, that's another discussion. But diet, as important as eating is the time you don't eat. Okay, we need to not eat too much. We have to work on volume, frequency, and quality of food. These are other discussions. I'm just right now trying to give you the metabolic approach, and understand that all the therapies we use, other than IPT, are metabolic therapies. All the dietary changes and cleaning the colon, all these things fall under metabolic. We're changing the metabolism. Metabolism is the activity of cells. So if you change their activity back to what they were as healthy cells, then they're no longer going to be cancer cells. So that's why this metabolic approach is very important.